Hello everybody, welcome back to another video in the calculus series. If you're enjoying the series so far, make sure to leave a like, subscribe to the channel, and follow along. So today we're going to be talking about graphing both linear equations and linear inequalities. The last video we did was all about inequalities, so I feel like this is a nice successor to that video. Most of the time, when we start graphing, we're going to use the y-intercept form, which is y equals mx plus b. Here we have two really important players. Our m, which is our slope. This tells us how much our line is changing, how fast it's going up or down. And then our b, which is our intercept. This is kind of our starting point. So let's go ahead and draw a graph and we'll show a simple example here. Let's do an equation y equals 3x plus 1. And then let's go ahead and draw some tally marks on our graph here. And then we'll go this way as well in the negative x direction, and then we'll do our negative y. Okay, so to graph this, we're going to first start with our b, which in this instance is just 1. So right here on the graph, we're going to plot 0, 1. Remember, this is our x and this is our y value. Our intercept, our b, tells us where we start on the y-axis. So our x is always going to be 0. From here we can start building up other ordered pairs as well. And if you remember the mnemonic or the little phrase that you might have learned in Algebra 1, rise over run, we see that anytime our slope has a fraction, let's go ahead and give an example. This is just a hypothetical. If we had 3 over 2, then we would go up 3 and over 2. In this instance, though, we have just 3, which we can rewrite as 3 over 1, because 3 divided by 1 is just itself, it's just 3. So we're allowed to write it that way. And what this tells us is we go up 3 and over 1. So on the graph here, we're going to start at our 0, 1, and then we can go up 1, 2, 3, and over 1. And then we can repeat that, and over 1, and over 1, until you run out of space on your graph. And then we can do the exact same thing going down. So if we start at 0, 1, we can go 1, 2, 3, over 1, 2, 3, 2, 3, and let's do one more. Okay, now we've built out this line. It looks like my line isn't very straight, but it's okay. Let's go ahead and draw this line. Make it match up with the points as much as possible. Okay, there we go. So that's how you draw a linear equation when you're given the y-intercept form. There's other forms as well, but this is a pretty common one that you're going to use for graphing. And a linear equation is just an equation that has an x to the power of 1. So our order is just 1. Sorry, that shouldn't be x equals 1. It should be order equals 1. That's really important because we know our line is always going to be flat with these kinds of equations, whereas if we had x squared, we'd probably end up with a parabola shape, and then if we had like x cubed, we'd end up with this goofy half parabola shape going either way. So that's why linear equations are important. It's a nice starting point in algebra as well. So let's go ahead and look at another example now. Let's use a fraction for m just to get the feel for it. Okay. And I'm going to erase that graph just because I didn't love it. Let's go there. Okay. Although this graph looks a little lopsided, but it's fine. Okay. Let's go ahead and try y equals negative 3 over 2 x minus 2. Let's do plus 2 actually. Okay. Let's go ahead and put our notches here into our graph. These notches represent 1 increments for these axes. So as I'm going down in the negative y direction, each increment would be negative y equals, or y equals negative 1, negative 2, negative 3, and so on. Okay, here we have a very rough graph, but again, it doesn't matter. Okay, so again, we start with our b, which is 2. We're going to start right here at 0, 2. And then we're going to build our graph, or our line, from our slope. So again, our slope is rise over run, but now our rise is going to be negative. So instead of going up and to the right, we're going to go down and to the right. So we start here, and we're going to count 1, 2, 3, and over, instead of just 1, now we're going over 2. So right here, 1, 2, 3, 1, 2, and we can just kind of graph out these stair steps and continue down the graph like so. And then same thing going up and to the left, we're going to go up 3 over 2. Oops, should be right there. You know? Yeah, no, this is fine. Okay. And then we see that we're just about done here. Let's go ahead and draw a line through these points now. Okay. So that's a very basic way to start graphing. It's very nice and easy. The other method is that we can just plug in y's and x values. So, for example, if we know, if we know the equation for y, we can plug in an x to find y. So let's say we want x equals 1. Then we plug in x to this equation. Negative 3 over 2 times 1 is just negative 3 over 2 plus 2. So we can do y equals 2 over 1, or we can make it 4 over 2 minus 3 over 2. So notice that our 2 here became 4 over 2, and I just moved over the negative 3 over 2 just to make it look a little bit better. So y equals 1/2. So what this is telling us is when x equals 1 right here on our line, then we should be at about 1/2, which is there. Again, this graph is not extremely well made just because I didn't put as much attention into these dashes as I should have, but it's okay. This works for any point. So if you want to know any corresponding y at any x, we can plug that x in and find that y. Or we can move over the equation to find the x. So if we have y equals negative 3 over 2x plus b plus, let's actually use an example, 2. We first move over the 2 to get y minus 2 equals negative 3 over 2x, and then we multiply by the inverse here, so 2 over 3, negative 2 over 3. We get y times 2 over 3, and that's negative, plus 2 times 2, which is 4 over 3. Or x equals negative 2 over 3 y plus 4 over 3. So instead of starting with any x and finding the corresponding y, we can also find the corresponding x to a known y. Let's go ahead and show how to graph inequalities now. Inequalities, especially graphing, seems to confuse a lot of people. So let's go ahead and make a good example here. Sorry, I'm just counting because I want this one to look a little bit better. Okay. And then let's do every half square. Just because inequalities can be so confusing, I'm wanting to do this pretty accurately here. Graphing paper helps a lot whenever you're graphing. Funny how that works. Just because following these squares can be really nice and simple, whereas doing this on a blank piece of paper or even a lined piece of paper can, your graphs end up looking more like my earlier ones than this one. So let's now go ahead and do y is greater than negative, let's do positive, 1/2 x minus 1. So again, we start with our b, which is minus 1, or 0 comma negative 1, and then we look at our relationship, again, rise over run. So we go up and over 2. Up 1 over 2. And this one is fairly simple. Okay, there's that side. And then we're going to go ahead and do the same over here. Okay, so now we have our line. But whenever we're doing an inequality, this inequality is telling us a range of numbers that are allowed. So in this instance, it's any number that's greater than this line here. So this line that we've created is the condition that we have to meet. All our values have to be greater than this line. So what we end up doing is filling in the graph everywhere that's above this line. And then we look at our inequality. Here we have a y is greater than this equation. So that's why it's above it, because it's greater than that equation. And because it's not equal to, we need to end up making our lines here dashed. And that's how you graph an inequality. If we had y is greater than or equal to, then we would make this line here solid. Let's go ahead and do another example. And if I could keep this graph, that would be amazing. There we go, I think I got it. Okay. Just gotta fix up a few of these. So now we're going to do y is less than negative 3 over 2 minus 2. So we're going to start at 0, comma, negative 2, which is right here, and then we're going to go over 2 and down 3. So right here, here, and then the next one would be off the graph. And then we're going to go to the left, over 2, up 3. Right here. And there we go. So now our y is smaller than this line. So everywhere this line is, we know we have to be below because our y is less than. So we go ahead and we fill this in, same as last time, but now we're below the line. And then again, because this is less than and not equal to, our line will be dashed. Like this. If we were to make it less than or equal to again, we would go ahead and fill this in. If I could follow the line. There we go. That looks a little rough, but it's okay. So, this is how you graph both linear equations and linear inequalities. If you enjoyed the video, make sure to leave a thumbs up and look at some of the other videos. We're really covering fundamental things right now before moving into calculus. I feel like a lot of these concepts are really what students struggle with, so I want to provide videos outlining these concepts before moving into the later calculus stuff, so anytime we get to a complicated idea in calculus, I can refer back to these videos for individuals that struggle with these concepts. Anyways, thank you so much for watching, and have a good day.